Hi, I'm Anika Chebrolu and I'm an 8th grader from Frisco, Texas. Today, I want to present you with a way to improve the health of our future generations, a potential cure to the influenza virus. Every year, there are nearly 45 million cases of influenza across the world and over 60,000 deaths in our country alone due to the influenza virus, in spite of the current drugs on the market. Therefore, there's a compelling need for the development of newer and more effective drugs to combat the influenza virus.
In order to create an anti-influenza drug, I needed to find a ligand to bind to an important protein of the influenza virion. The hemagglutinin protein is responsible for facilitating the entry of the virus into host cells and appeared to be a promising drug target because inhibiting this protein would stop the virus in its first stages. Further, there is no drug on the U.S. market that exploits this mechanism. To prepare the hemagglutinin protein for screening, I had to identify the best binding site on the hemagglutinin protein. I downloaded the protein from the RCSB PDB database and used the FTMap computational mapping web tool to find the best druggable hotspot on the protein. The S1 site, which is the largest consensus site on the hemagglutinin protein, was chosen. My next step was to obtain the three-dimensional structures of all the drug-like molecules from the Zinc-15 small molecule database. The database had about 3 million small molecules, and I screened these through Lipinski's rule of 5, and only about 250,000 molecules passed. These 250,000 selected molecules were then subjected to an initial molecular docking test using the CLC Drug Discovery Workbench software. This software was used to find the top 100 molecules with the highest binding affinity to the given druggable binding site on the hemagglutinin protein. These top 100 molecules were then tested for ADMET properties using the ADMET-SAR 2.0 web tool. Only 6 of these molecules passed the given ADMET properties. These 6 molecules were then put through a more comprehensive and thorough binding energy test using the Autodoc Vina program in the Pyrex software. Finally, a lead molecule was declared with the excellent binding affinity of negative 8.2 kilocalories per molecule.
From the initial 3 million compounds, I was able to narrow down to one potential drug candidate that can successfully bind and selectively inhibit the hemagglutinin protein of the influenza virus and can be further developed as a novel therapy for the treatment of influenza. Thank you for your attention.